This is part 4 of the Pressomar PLM600-E installation. In this part of the video, we will show you how to power up and verify the machine. The first step is to turn the MAR Econ or MAR E controller on. The white box inside the cabinet, power switch to the 1. It takes approximately 15 seconds for it to come up, and you'll hear the relay click. Once the relay clicks, we can turn the power on for the PC. And then we'll let it come up to the desktop. The PC comes up to the desktop, but it's very critical that you wait until the black window comes up, this one, and it says start MAR Econ, service is running, and then it disappears. At that point, you can open the software by clicking on Pressomar 828 Win. As you come up to the initial screen, the password is CFMAR, CFMAHR, all caps. Next screen is the reference point run. Make sure everything is clear from the table, the headstock. Click the green arrow to start. First, the table goes down. It always moves down first and then comes back up approximately half the travel. Once it reaches half the travel, that's going to be the reference mark, and you get the green check mark. The Y is next, which is moving the table front to back. And then the last step is TB, which is the tilt side to side. Every time getting the green check mark. And then last is the X, which is the headstock. Approximately center of the 8-inch glass scale. So here it has found all the reference marks. We see the checks, but it's still moving because the axes are going back to the home position. TB is still moving. Once it hits 0, then you have the OK available. Now the machine is ready to measure. For verification purposes, we go into free measurement static, OD measurement. And here we can see the X, TZ, TY, and this is where you put in the size of your gauge blocks. This is where you select the measuring force. So the first step we're going to do is verify the measuring force. For verifying the measuring force, you'll need a force gauge set to newtons, the internal jaw with the hook, and the first step in the software is to go to the top, Functions, Utilities, Zero Spindle Deflection without the spindle touching anything. Start brings it to 0, the probe inside the headstock, and then you hit OK. This is the neutral position of the measuring probe for the force inside the headstock. Next, we will measure and verify the ID measuring forces. In the drop-down window, we see it's in newtons. We select 1 newton. Hit the contact to the right button for ID. The headstock moves into contact. We have minus 1.00. In the drop down, we go to 2 newton. Contact right again. It resets the measuring force. Comes over 2.02 newtons. Well within tolerance. Tolerance is 10% of the reading. 3 newton. Contact touches 3.01 newtons. Next will be 4. Contact 4.0. It's toggling between 5 and 6. So typically with ID measurements, since you have this jaw and a single point of contact, we only go up to 4 newtons, which is about 16 ounces. Any more than that and you can damage the eye jaw as well as the part you're actually measuring. So next we'll skip to the OD verification. For OD measurement force verification, we use the slip-on ball anvil. Going straight to the force gauge is zeroed out with nothing touching. We can verify function utility, 0 spindle deflection. It's at 0, so that's good. With no contact, it should be at or near 0. So in our drop down, we'll start with 1 newton. Now we contact to the left for OD measurement. Headstock comes in, touches the force gauge, 1.01 newton. Okay, really good. Drop down, get 2 newton. Contact left. Headstock comes in at the new force, 2.01 newton. 3 newton. Contact. 3.01. 4. Contact. 4.01. 5. Contact. 5.01. 8. Contact. 8.00. Contact. 11 newtons is 10.978 newtons. So this machine is really, really good. The tolerance is 10% of the nominal. So 1 newton would be up to 1.1, down to 0.9, and so on. Next will be linearity verification of the PLM600-E. This is done with gauge blocks. We use ceramic gauge blocks. We start with the 1/2 inch master and then measure 1, 2, 3, 4, 5, 6, 7, and 8 inch gauge block. For verification of the machine using gauge blocks, you always want to use these slip-on ball anvils so that you have one point of contact to the gauge block. The next step is back the tailstock off so that you have full range of the headstock, and you want to move all the way to the left position. Until it stops, and then you'll see limit switch X left. And then you want to bring the table over close but not touching, and then bring the tailstock up close but not touching the ball anvils together. This will be your start position to start measuring the gauge blocks. For verification on the gauge blocks, it's best to use 4 newtons. This way, the 1/2 inch as well as the 1 inch rectangular blocks are able to be suspended between the anvils with their weight only. We'll now demonstrate that. So here we have the calibration size as 1/2 inch plus 1/100th, and that came from our gauge block cert. Measuring force is 4 newtons. So the 1/2 inch is able to be suspended. If you spin it around like that, it will automatically find the lowest point. And then from there, you can go accept, and that accepts the 1/2 inch plus 1/100th into the X. You go OK, and it switches into the free measurement screen. So now we're ready to make our first measurement on the 1 inch gauge block. He's removing the 1/2 inch, putting the inch in, contacting. Same thing on the 1 inch, you're able to spin it, and it will self-align to the lowest reading. In this instance, sometimes it takes a couple tries, depending on the balance and the position that you're measuring. You want to be close to the center of the block. And it'll go back and forth, and eventually it'll settle in. And you can watch it on the screen as it slowly gets smaller. And then this reading is about 1 inch plus 6 or 7 millionths. And we can hit the green button to take the reading, and it comes up in this window, actual value. And then we'll move on to the 2 inch block. For the 2 inch or larger gauge blocks, you can put those on a pin gauge in the center of the table, and you can tap the gauge block in all directions, left, right, up, down, while looking for the lowest reading. So he's going to tap the gauge block now. He tapped it once and it went the wrong direction, so now he's going to the other side. all the time looking for the smallest reading. Starts going up, go the other side. So that's what it looks like on the screen, and this is what it looks like here. He's tapping on top right, it started growing, so then he goes to the top left, and then front to back. He hits there until it starts growing, and then he comes back from the other side. Always looking for the lowest reading. In this example, it's 2 inch plus 19 millionths. So you have to account for the gauge block deviation would be figured into this result, and anything that is off from there could be due to temperature. So this block is reading a little large, and as you can see, we're at 70.7 degrees. So that could explain that offset very easily. So that's the 2 inch, and then you want to step through every inch, and this machine has an 8 inch glass scale. So you would go all the way out to 8 inches and either write down your readings, or you can use the software to record the actual readings. To check the parallelism of the anvils, you can use a precision CMM ball probe in the center of the anvils and zero the reading out. So the X is zeroed, and then you can slide the ball towards the back of the anvils and note the reading. Then go towards the front and note the reading. Top. And you can't go all the way to the edge. You have to back off the edge a little bit. If you go to the very edge, the anvil starts to fall away just because of the way it's made. So you should be away from the edge. And also critical, he's going to the bottom now. You want to try not to turn the ball, because if the ball isn't perfectly round, then you'll see some deviation there as well. So zero at the center of the anvils, go top, bottom, front, back, and note the deviation. And the tolerance on that is 8 millionths of an inch. But you have to be critical to stay away from the edges and don't turn the ball at all. Also, when measuring the parallelism, you want to use either 1 or 2 newtons force, because you want a light pressure so that sliding the ball on the anvil doesn't affect the reading. If you measure the gauge blocks and you find that the linearity is out on the gauge, for instance, the further you go away from your 1/2 inch master, the larger it measures and continues larger all the way out, you can go into General Settings, Basic Configuration, and inside here there's a tab labeled Machine, and then there's a linear increase factor, and it's based on microns per 100 millimeters. So in this case, this machine was reading 0.4 microns small on the 100 millimeter gauge block, so we entered 0.4 to increase the value by 0.4 microns on the 100 millimeter gauge block. This will also increase the 200 millimeter gauge block by 0.8 microns.